and turn that off. All right. Let's see what's going on here. So the topic of today's lecture is char and string. So this is, I guess this is using strings going to be the first big departure for C programmers. Because Java actually has a special type called string that makes working with sequences of characters much more convenient than it is in C. Now, I should tell you that it is a lot more convenient than working with strings. Using the string class in Java is a lot easier. It's a lot more pleasant to do in Java than it is to do in C. But you do pay a price in terms of computation, in terms of computational cost. So I'm not sure how much they showed you in C. I'm not sure how much they explained to you what exactly happens when you use a string. But it's very easy to use a Java string and end up with relatively poor computational performance, just because of the way that the string class works. Now, that's not really an issue for us, and it's not really an issue for most software programs, but it can be a problem. Anyway, let's go. Let's get started here. Okay, so a string literal, which we've seen already, right? Something inside double quotes, right? It's just a sequence of characters between double quotes, right? And now the term sequence is important because a sequence means that there's the order of the characters is important, right? It also suggests that perhaps you can get to an individual character in the sequence, right? And that's true with the Java string. So the characters making up a string, in Java, they have the primitive type char, which is also true in C. Right? So if because this is a sequence, if I want to get the first sequence of the, if I want to get the first character in the string that's referenced by S, I can write s dot char at 0. Okay, so that's how you write that. I'm going to explain this syntax in a moment. Now, if you want to write down a char literal, so if you want to write down a char, then you have to put it inside of single quotes. There must be exactly one character inside the quotes, right? So there has to be a single letter or a symbol inside the quotes. So you can have a space, that's fine, right? You can have the letter A. You cannot have nothing, right? So you can't have single quote, right? That won't compile in either C or Java. So there's no such thing as an empty char, right? Just like there's no such thing as an empty int, right? If you make an int variable, it has some value, even if you haven't set it, right? And it's got some value. So as in C, char is actually an integer type. Right? Now the difference, one of the differences between a Java char and a C char is that Java actually says exactly what the value, exactly how you should interpret the char value. Right? So the Java language specification says a char is an integer value that is mapped to a character, and the mapping is defined by something called the Unicode Standard, and it even specifies the version. So it's version 6 of the Unicode Standard, right? And C doesn't say this. So the Unicode Standard is a standard that's intended to define a mapping between integer numbers and every possible symbol, every possible written symbol that you can come up with for every language, right? So for every, I guess, earth-bound language, right? So you have, it defines characters for all of the different languages, all of the different spoken/written languages in the world. You also get things like emojis and things like that, right? So you get all sorts of graphical symbols as well. In Java, Java also says that a char has exactly 16 bits and it's unsigned, right? So there's no negative char values. So if you print out character min value, that's the number 0. If you print out character max value, that's the number 65,535. Right, so that's 2 to the 16 minus 1. Right. Now, notice that I have to do something funny here. I need a cast, right? And you've seen casts in C, right? I have to cast the value of character min value to an int in order to get the number 0. And I have to cast max value to an int in order to get the number 65,535. And that's because of the way that print line works. The way print line works is that if you pass it a char value here as its argument, right, it tries to print out the symbol corresponding to that char value. Right. So if I just wrote system out print line and then character min value, it would actually print nothing because the character 0, it turns out that maps to a non-printing character. I don't know what max value prints out, but I don't think it prints I don't think it prints anything sensible to your screen either. Right. So you need the cast here in order to get a number out. Now, because chars are actually integer values, you can actually store an integer in a char as long as it fits inside this range. Right? So as long as the number that you write is inside this range, you can actually store that number in a char variable C. Right? When you print it out, though, you get the symbol that it corresponds to. Right? So if I set C to 65 and I print it out, you get the capital letter A. Right? If I add 25 to C, so C equals C plus 25, right? You get the letter Z, capital Z, right? Which sort of makes sense if you think about it for a second, right? If I go 25 characters past the letter A, I end up at the letter Z, right? And so that's what that does here. So the mapping is, it's somewhat sensible in the ordering of the characters, right? So your letters aren't scattered randomly throughout. Exactly how the mapping works, it's not important to us. Okay, now, because char is an integer value, you can actually do arithmetic with it. But in Java, the results are unintuitive. So in C, if you do arithmetic with a char, it works exactly the way you think, right? Because C is very lenient on types, right? So if you add a value to a char, it tends to give you, so when you write in expressions like this, for example, in C, that works. In Java, it doesn't work because of the way that the arithmetic rules are defined in Java. So it's a little bit funny when you try to do arithmetic with char. So I'm going to start out with the letter A, right? Capital A. I'm going to write C++, which is fine. That actually works. If you type it into your compiler, that works just fine. And that adds 1 to C. So it turns C, if you print out C now, you get capital letter B. Right? If you write C plus equals 1, that also works, right? So now if I print out C, I'm going to get the capital letter C, right? So here's A, add 1, that's B, add another 1, that's C, right? Minus equals works, right? So C minus equals 1 works, so that gets you back to B, right? Now, oddly enough, what doesn't work is if you write something like this. When I write C equals C plus 1, Java applies its, so Java sees a char, and it sees an int, right? So 1 is 1 with no suffix after it is an int value. So the way arithmetic works in Java is it converts the char value of C to an int value because it sees an int and a char. Ints in Java are wider than chars, right? So they take up more memory. So the rule in Java is it takes the narrower type and converts its value to the wider type. Right. So the value of C gets converted to an int, and then these get added using int arithmetic. And now you have an int on this side, and you're not allowed to store an int in a char in Java. Right. So you end up with this error. So the compiler says, I can't, oops, sorry. The compiler will tell you it can't convert from int to char when you try to store the answer back in C. The way these operators are defined, right? So the way plus equals and minus equals and plus plus are defined, everything happens. Everything works the way you expect it to. Well, it almost works the way you expect it to. It seems to work, right? The exact details are not relevant right now. I think they're described in one of the notebooks, exactly how this works. Right? It gets a little weirder, right? So this one you might accept, right? But it gets a little stranger. If I make another char variable called D and set its value to capital B, right? Then you might think, well, I can now add C and D, right? Because C is a char and D is a char. right? But the compiler, again, will tell you it cannot convert from int to char. And the reason is because when you try to do arithmetic with any integer type that's smaller or narrower than int, right? So if you try to do it with byte, short, or char, then what Java does is it automatically converts both values to int and computes the value as an int, right? So no matter what you do, if you try to do a char plus something, right, some integer type on this side, you get back at least an int, right, instead of a char. So if you want to do this for some reason, you have to put all of this in parentheses and then cast the result to char before you store it back in E. Now, you normally don't do arithmetic with char, so usually you don't have to worry about this. And furthermore, the compiler will tell you that there's an error. So you don't have to worry that you compile your program and it runs, right? It won't run. Now, why would you want to do arithmetic with char? Because it is occasionally useful if you want to generate characters computationally. Right. So for example, suppose I want to make all pairs of 2-letter uppercase strings, right? So AA, AB, AC, AD, and so on, up to ZZ, right? Then the way you can do that is you can write a pair of nested loops. Right? So C is going to be the first letter of my 2-letter word. D will be the second letter of my 2-letter word, right? And I'm going to write a loop. So I'm going to start at A, right? A outer loop will run as long as C is smaller than or equal to Z, right? So A, B, C, D, all the way through Z, right? Each time through the loop, I can advance the character C by 1. And then I'm going to write the exact same thing for the inner loop, right? So D will start at A. The inner loop will run as long as D is less than or equal to Z. Each iteration of the loop, I'm going to advance D by 1, right, to the next letter, right? And then I can build the string, right? So I start with the empty string, and then I concatenate the character C to the empty string, and then I concatenate the letter D to the result, right? So this gives me the empty string plus A, which is AA, right? Next iteration of the loop, it'll give me the empty string plus A plus B, which gives you AB, and so on and so on and so forth. Right? So if you ever need to loop over the letters of the alphabet, or perhaps loop over the numbers, the digits of the numbers, or something like that, you can use a loop. Right? And that turns out to be useful in these types of problems. Okay. So I now want to tell you about this thing called string. But before I can tell you about that, I have to explain what I mean by some certain phrases. So there are these things in many programming languages, well, many object-oriented programming languages anyway. So there are these things called types. So you've seen these in C. There are these things called classes, and there are these things called objects. All right, so what's a type? So a type is something like int or char or double, right? Or in this in an object-oriented programming language, it's also something like string, for example. So a type is a set of values and the operations that you can do with those values, right? So you know what the int values are, right? They're the integer numbers between some value and some other value, right? So that's the set of values of ints. Those are the set of int values, right? What operations can you do with int? Well, you can add them, subtract them, divide them, right? So you can do arithmetic. You can compare them, less than and greater than, right? You can check for equality. And you can do a few other things, but that's about it, right? So that's what a type is. Right? Now, a class in Java is a user-defined reference type. Right? So when you make a class in Java, you end up with a new type, right? And the type can take on a certain set of values, right? And it can have some operations that you can do with the type. Now, an object is what we say is an instance of a class. Right? So let's use int as an example, right? So int is a type. We can say that an instance of an int would be the number 0, for example. Right? If you have a reference type, it's a class, probably a class, right? So an object is just an instance of that class, right? So the string ABC would be an instance of the class capital S string. All right. So string's a class, right? Big S string's a class, which means it's a type. If I have an object of type string, right, then that represents text, right? Some sequence of characters. Turns out it's very, very widely used in in many Java programs, right? The string class is considered fundamental to the language. And it's strings are so widely used that the Java language actually goes out of its way to let the programmer do things with string objects that you can't do with any other type of object. Right, so it's a little bit strange for programmers new to Java because the way you use a string is quite different than the way you use any other type of class. So, for example, string literals exist, right? So I can write double quote, some stuff in between the double quotes, and that gives me back a string object, right? There are no literals for any other reference type in the Java language. And there's no way for a programmer to create a literal for any other reference type in the language. Right, so that's one big difference between string and every other reference type. The other major difference is string has this plus operator. Right, so the addition operator is string concatenation, but there are no other arithmetic or comparison operators defined for any other reference type, right? So you can't make your own class and say that plus does something for your class. You can't make your own class and say that less than does something for your class, right? So you can't do that sort of thing in Java. Now, other programming languages you can. So for example, the C++ programming language, which I'm pretty sure many of you will end up learning at some point in undergrad, you can actually redefine the operators for your type, right? So you can make types, you have classes in C++, and you can redefine the meaning of the operators in C++. Can't do that in Java. Okay, I should show you this because it's going to be useful at some point. So let me just bring up a web browser quickly. All right, so I'm going to type into my search bar, Java, some version of the language. I'm just going to use 8 for now. You can use 17 or whatever you want, and then type in string, and then you should get the documentation for the string class. When you look at the Java documentation for the first time, it can be overwhelming because there's a lot of documentation. Right, you got a lot of links up here that that do something, right? And then there's a lot of stuff here that you probably don't completely understand yet at this point in the course, right? But that's fine. Up at the top here, so after the introductory material, you get a description of what the class does. Right, I'm going to skip over this for now. It's just telling you that, well, it tells you some stuff about strings that I've already told you. Right, if you keep on scrolling, you'll get to this section called the constructor summary. For now, you can ignore this because you normally don't use string constructors anyway. I'm going to tell you about constructors probably in a week or so. And then finally, we get down to the methods. So these are the parts that interest us. Right? So the methods are the operations that you can do with a string type. Right, so remember I told you that a type is the set of values, and the operations that you can do with the values. Well, these are the operations that you can do with the values. And so you can see here, these list all of the methods that you can call with a string. Right, so we'll come back to this in a little bit. The other thing you need to know about string is that string objects are immutable. Right, so immutable means you cannot change them. So once you make a sequence of characters in a string as a string object, that string object can never be changed. Right? So suppose I write down the string hello inside double quotes, right? Then there's a string object that corresponds to the sequence of characters HELLO, right? And that string object, you can never change the sequence of characters, right? So I can't go into that string and make the H a capital H, for example, or I can't delete the O or I can't change the E to an A or something like that. Right? So string objects are immutable, unchangeable. Right? Now, there's a bunch of methods in the string class that seem like they change the characters of a string. Right? So for example, there's a to uppercase and to lowercase. Right? Those methods don't actually change the string. What they do is they compute a new string and return a reference to the newly computed string. Right? That's one of the reasons why strings are computationally expensive in Java. So when you do something with a string that seems to change it, it doesn't in fact change the string. It gives you back a new string. All right, so keep that in mind. So to uppercase and to lowercase. These are methods that return uppercase and lowercase versions of a string. Right? Again, without modifying the original string. Right? So I'm going to make the string object hello. Right? My variable s, that's going to be a reference to the string object here. Okay. I'm going to call to uppercase using the string using the variable s. Right. So this syntax here, s dot to uppercase, means right. Find the variable s. Right. Get the object that s refers to, and then ask that object to perform this action. Right. So here, this is asking the string hello to perform the action to uppercase. Right? And what that does is so what this does is it computes a new string that's capital H, capital E, capital L, capital L, capital O. Right? And it stores a reference to that string in the variable up. So when I print out the variable s, you get back the original string hello. When I print out the variable up, I get back the new uppercase version of hello, right? So capital H, capital E, capital L, capital L, capital O. Right? So this method here, it does not change the string object that s refers to, right? It gives you back a new string. So one of the most common errors that you see new Java programmers make is they say, well, I've got the string hello and I want to turn it to uppercase. So they write s to uppercase, which compiles. Right? So the compiler is perfectly happy to do that. Right? Again, what does this do? Well, it asks that object to perform the to uppercase method. Right? So it does. Right? It computes big H, big E, big L, big L, big O, and then returns that string object. Now, there's no variable over here, so the returned value just gets discarded. Right? So that string that was created, you don't have access to it anymore. Right? But it doesn't change s, so s is still lowercase hello. So keep that in mind when you work with the string class, or any other class that says its types are immutable, its objects are immutable. Right? So the string class is not the only class that that represents an immutable type in Java. Let's go back and look at the documentation for string. Right? I've told you that right now, whenever you make a class, your methods are static, right? They're public and static. The documentation for a class, it normally shows you the public methods in a class, right? So all the methods that are visible to any other class. If a method has some other access modifier and it appears in the documentation, then the modifier will also appear, right? So if you don't see a modifier, the method's public. If you don't see static, right, and we don't see static here, then the method is just a regular method in the class. If we scroll all the way down, whoa, sorry, too far. If we scroll down to the summary, end of the summary, here, right, you see that there are some static methods in the string class. Right? So there's these methods called value of that are all static. Right? So when you use value of, you have to use big S string dot value of. Right? So whenever you see a static method, you use the name of the class to call the static method. If you see a non-static method, then you need an object to call the method. Right? So to lowercase, right? is not a static method, which means when you call to uppercase, you need a string object to call the method, right? So I need a variable of type string in order to call to uppercase, right? If you write big S string to uppercase, that doesn't work. So here I need to use an object. I use the object referred to by S to call the method to uppercase. So as I just told you, string does in fact have static methods as well. Right? So if I want to use value of, I use big S string dot value of, right? And then a number. So value of will take this primitive type here and produce its string representation. Right, so this will give me the string representation of the double value 1.0. Right, you don't have to use the method value of. Right, instead, you can always construct an object corresponding to a primitive type, a string object corresponding to a primitive type, by writing the empty string plus the value that you want. Right, this is shorter. This is easier to write than that. I don't know if they do exactly the same thing computationally or not. The result is the same. I don't know if they do it the exact same way. Okay. Now, one of the things you want to do with strings is you want to test if two strings are equal, right? So do they represent the same sequence of characters? So here I've got two strings. Right? I've got the string lowercase hello. Now T is weird, so we haven't done this yet. So this is your first example of calling a constructor in Java. So let's go back to the documentation, string. So the first thing you see in a class after the description of the class, usually you won't see the field summary. So let's skip past that part. The next thing you'll see is what's called the constructor summary. Right? So a constructor it looks like a method, but it's not a method in Java. Right? So the Java language says specifically constructors are not methods. So a constructor is, I don't know, well, it's the thing that you use to initialize a new object in Java. Right? So the string constructor, the name of the constructor always matches the name of the class. Right? So all of the string constructors have the name big S string. Right, and then there are these round brackets, and then you can pass in some arguments to the constructor. Right now, let's see. So there are some string constructors here that you can use, but you almost never use a string constructor when you use the string class. Right now, here I'm using one. So here I'm calling a string constructor. So the way you call a constructor is you use the keyword new, right? Constructor name. And then whatever parameters or whatever arguments you need to call the constructor. So here I'm calling the string constructor with another string, right? So this is inside double quotes, so that's actually another string. Normally you don't do this. Normally you just write s equals hello because the language lets you use literals for strings. But I'm going to do this here for the purposes of using equals. If I want to test if the strings s and t are equal, so do they have the same sequence of characters, you should use the equals method, right? So s dot equals t, right? If you run this, the value of bool will be true, right? They're both the sequence of characters HELLO. Right? Now, if you have primitive types, right, you do the normal C thing, right? You use equals equals or not equals, right? Now, if you do this here, all right, bool equals s equals t, you get back the answer false, right? And that's because equals equals is not what's called logical equality in Java, right? So equals equals means equality of identity in Java. So when you use it with a reference type, it means the variables s and t refer to the exact same string object, right? So do the variables s and t, do they refer or point to the exact same string object? Right? So in this example here, s points to the object represented by that string, right? T points to the object represented by this, that's created by this line here, right? So they actually point to two different string objects. The two string objects are logically equal, right? They have the same sequence of characters, but their identities are different, right? They're actually two different string objects. So equals equals here returns false. Right? The probably the most common, one of the most common errors made by new Java programmers is that they compare strings using equals equals and not equals, instead of using dot equals and not s dot equals t. So if you're ever comparing strings for equality, remember to use the equals method. The problem is the Java language goes out of its way to avoid making new string objects. Right? So that's the problem. So if you write s equals the string hello, and then on the next line you write t equals the string hello, right? Then it turns out what actually happens in Java is they both point to the same string object. Right? So the string class does some work to determine whether or not this string object already exists. If it does, then it avoids making a new string object. Right? Exactly how it does that is beyond the scope of this lecture. Right? You don't need to know how it does that right now. Now, because they point to the same string object, that works. Right? It gives you back true. And it seems to work most of the time. Right? So if you write a small program, this seems to work almost all of the time. Right? It's not until you try to do that in a bigger program and then suddenly it doesn't work some of the time and you have to track down a very hard to find bug that you run into a problem. Right? All right, so a string is a sequence and it turns out it's a numbered, oh, I forgot to change this. This is supposed to be CMPE, sorry. A string is a numbered sequence, right? Which means you can access the individual elements of the string using an index, right? So you can use an integer index starting at 0, right? So this string here is 7 characters long. So the valid indexes are from 0 through 6. The number of characters in a string is called its length, right? And it's returned by the method called length. So, oh, I forgot to change this too. Well, that sucks. These are all supposed to be changed to CMPE 212. So if I make a string called course name, and then I want to know how long that name is, it's course name dot length round brackets. That gives you back 7. Right? Java strings are not null terminated like C strings are. Right? So the amount of storage needed by that is 7. It's not 8. Right? In C, you would need 1 byte of storage for each letter, and then you need another byte for the null terminator. Right? In Java, that's not true. There is something called the empty string, right? So if you write double quotes with nothing in between, you get what's called the empty string object. So if you ask the empty string for its length, you get back 0. This is something else you have to remember when working with Java strings. A string might be empty. So you can't assume that a string has some characters in it because it might not. If you want to get an individual character from a string, you use the method char at. Right? So you pass in an index, right? And that gives you the character at that index. So for example, if I want to scroll through quick. Oh, I did change them. Okay, I thought I changed these, but I guess I missed the earlier ones. All right. So if you want to print out the individual characters of this string, right, you write a little loop. Right? You start at index 0. You go up to, but not including the length of the string, right? And then you use char at to get each individual string, right? So unlike a C string, you cannot use the square brackets to access a character of the string, right? Because in C, a string is just a null terminated array of char. So whatever you can do with arrays in C, you can do with a C string. That's not true in Java. So in Java, if you want to get a character, you have to use the method char at. If you want to count the number of times a specified character appears in a string, you can write a little method. Right, so here I've got my class called strings with an S. Right, I've got a public static method that counts the number of times that character appears in the string S. Right, so what do? Well, you set the count to 0. You loop over the characters of the string. Right, inside the loop, you just ask for the ith character and compare it to target. Right, now notice the type of target is lowercase char. Right, so it's a primitive type, so I can safely use equals equals here, or I have to use equals equals. Right, there is no dot equals for primitive types. Right, so whenever you compare primitive types, it's always equals equals or not equals. Right, so if the character is equal to the target, then I add 1 to the count, and then after the loop, you simply return the count. Right, so that's an example of using char at. And here's how you would use the method that we just wrote. Right, so inside of another class called test strings, I'm going to write a main method. Right, I'm going to make the string CMPE 212. Right, I want to count the number of times C. Haha, I didn't fix them all. I'll have to fix all of these on this slide. That should be 1. I want to count the number of times CMPE 212 appears in that string. Right, so I use my class name. Right, so remember the method here, freq, is defined in the class strings with an S. So strings.freq, course name C. Right, that should print 1. If you ask, now strings are case sensitive in Java. So if you ask for how many times the lowercase c appears here, that's 0. Right, if you ask for the number of times 2 appears, well, that's 2. Right? So that's how you would use the method that we just wrote. Okay, now strings have a whole bunch of methods, right? So when you go to read the string documentation, when you scroll down to the method summary, right, you'll see that there are literally dozens of methods, right? So I'm going to scroll for a little while, right? So there's lots and lots and lots of methods. Obviously, I'm not going to go through all of them. At some point, you should scan through the class to see what strings can do. But there is this method called contains. Right here, right? So contains takes in this thing called a char sequence. For right now, just read, instead of reading char sequence, just read string, right? So this will test if a string contains another string S, right? So I want to know, does the string CMPE 212, does it contain the string CMPE, right? The answer is yes, right? It's right there, right? Does it contain the string lowercase CMPE? The answer is no, right? Because strings are case sensitive. Does it contain the string 1? The answer is yes, right? Now, the string class is inconsistent because there are methods that take in chars and there are methods that take in strings. And there are methods that take in either a char or a string. Contains is not one of them, right? So if you want to know, does your string contain a particular character, it doesn't work. So if you ask, does the string contain the character big C? The compiler says, hey, I don't know how to do that, right? It'll complain. It says there is no method called contains that takes in a char, right? So you have to turn, if you want to search for the string C or the character C, right, you have to turn that character into a string. So one way to do that is to write the empty string plus the character C. Now, index of is one of these strange methods that takes in a string or a character. So index of returns the first location of a specified character or string. I'm pretty sure, actually. I'm pretty sure you can pass in there is a version that takes in a string, right? So you can see there's a version here that takes in a char. There's a version here that takes in a string. Right, so if I want to find the location of a specified character, you use index of. If the character is not in the string, the method returns -1. What's the index of the big C? Well, it's the first character in the string, so that's 0. Right, where's the P? Well, it's the third character in the string, so that returns back 2. Right, where's the 2? Well, there's 2 of them, so the method returns the location of the first one. Right, so that's 4. Is there a Z? The answer is no, so it returns -1. Sometimes you want the location of the last character in a string, right? So there's a corresponding method called last index of that returns the last location of a specified character in a string. Right? Where's the last C in the string? Well, there's only one. It's at the front, so that's 0. What about the P? Well, there's only one, so it's that. So that's 2. Well, what about the 2? Well, there's 2 2s. Right, so the last 2 appears at the end of the string, so that's going to be index 6. Right, and just like index of, if the letter is not in the string, you get back -1. Equals is the method that you should use to determine if 2 strings are represent the same sequence of characters. Right, so here I've got the 2 strings, CMPE 212 and Math 212. They're different sequences of characters. So when I write CMP equals math, the answer is false. Right, CMPE equals lowercase CMPE 212, the answer is also false, right? So equals is case sensitive. The plus operator we've seen lots of times, right? So you know that string concatenation. So I can join a bunch of strings together to produce a new string, right? So here I've got one string, James Bond 007. Here I've got 1, 2, 3 strings, right? But I'm going to join them all together to produce a 4th string, right? So that'll give me the string, well, James space Bond space 007, right? So is name 1 equal to name 2? The answer is yes. So the answer is true. If you are curious, you can try name 1 equals name 2 and see what you get. You can also concatenate, so you can concatenate any value onto a string in Java. Right? So you can concatenate primitive values onto a string. You can concatenate other objects onto the end of a string, right? And everything magically works in Java, right? So I can make another string, right? Starting with James Bond space, right? Then I can write +0, +0 +7, right? And that also gives me a string equal to that string there. So if you start with a string and add stuff onto the end of it, you get back the string that you expect, right? As long as there's no brackets on this over here, right? So as long as it's something plus a string plus something plus something plus something plus something, right? You get back the string representation of all of that stuff joined together. Now, you have to be very careful about the plus operator, right? So this is one of the reasons why Java doesn't let you redefine the operators for other types, right? You run into this problem, and you run into it with string, right? The operators have precedence, have all sorts of precedence rules associated with them, right? So if I try to compute the string h plus a plus ha, right? This does not do what you think it does, right? It looks like it's string concatenation, right? And that's probably what the programmer intended, but it doesn't work that way. So when you write an expression, something plus something plus something plus something, right? All that Java sees is a bunch of additions, right? And so Java says, well, there's no parentheses anywhere here. Everything's addition, so I'm going to compute the sum left to right, right? The same thing happens in C, right? So if you have an expression, an arithmetic expression with operators all having the same precedence, the computation goes left to right. So here, the first thing that Java sees is the character H plus the character A. That's a car, that's a car. So Java uses int arithmetic to compute the result, and you get 201. That's the value 201 plus a string. So now Java uses string concatenation, and it joins 201 with the string ha, right? And so instead of getting ha ha, you get 201 ha, which is very confusing, right? And you can do this, if you use parentheses, right? You can also cause weird things to happen when you attempt to use concatenation. Right, so one of the notebooks gives you back, actually goes through a bunch of examples where you can get strange results. Right, so you have to be a little bit careful about this. If you want to make sure that it always does concatenation, right? Then make sure the first thing in the sequence is a string, right? So here I can fix the problem by writing the empty string plus all of this. Right? That gives you back the string, haha. Right? Why does that work? Because the first thing in the sequence is a string. So when you go left to right, Java automatically does string concatenation here to give you back a string. Right? Then you get a string plus a character. So Java does string concatenation to get back a string. Then you get a string plus a string. So Java does string concatenation again. Right? So always make sure that the first thing in the sequence is a string, unless you are intentionally doing something unusual. What time do we have here? Okay, so substring. Sometimes it's useful to get part of a string, right? So some contiguous portion of the string, right? So substring is the method that lets you do that. And there's a few different versions of the method. So back to the documentation. So there's one version of substring where you pass in one index, right? And so it returns the string starting at this index, going to the end of the string. If I have the string A, B, C, D, E, F, G, and I write s.substring1, right? Then that gives you the string starting at index 1, going to the end of the string. Gives you back a new string, B, C, D, E, F, G. Right? Now the second version of the method, you pass in two indexes, right? That's the starting index. That's the end index. Return substring does not include the character at the end index, right? So this is the string of length 1, right? Starting at index 3. So 0, 1, 2, 3. So that's the string D. This is the string of length 2, right? So 7 minus 5, starting at index 5. So 0, 1, 2, 3, 4, 5. So that's the FG. So when you're using the second form of the method, right, you have to remember that the returned string does not include the character at the end index. Compare to is like the function string CMP in C if you've used it. I don't know if you have. So compare to lets you compare two strings by their dictionary order. Right? So if you have two strings referred to by S and T, right, then S dot compared to T returns a negative value if S comes before T, right? So ABC compared to XYZ returns some negative value because ABC comes before XYZ, right? S compared to T returns 0 if the two strings are equal, right? So ABC dot compared to ABC returns 0. Then S compared to T returns a positive integer if S comes after T in the dictionary, right? So XYZ dot compared to ABC returns some positive value, right? So compare to is like, less than, and greater than for reference types, right? So if the class has a compare to method, then the class is saying that you can put objects of this type, of this class, in order somehow, right? And the way you would do that is to use compare to, right? So similar to less than and greater than. Here's some examples. So if S is aardvark and T is zebra, right? S compared to T, well, aardvark comes before zebra, so you get a value less than 0, right? S compared to S, well, aardvark is the same string as aardvark, so you get 0. T compared to S, so zebra comes after aardvark, so you get a value that's greater than 0. And I'm going to stop there because we're at 19 after the hour. If you haven't noticed yet, on OnQ, I don't have it up. On OnQ, the full syllabus is now available to you. So if you go to OnQ, under the course description, you'll see the grading scheme and everything, including the date of your midterm. All right. So that's all I have for today. If you want to stay and ask questions, I can take a few questions. Otherwise, feel free to leave. Does anybody have any questions? Super. So we'll just end that there, and I will see you tomorrow.